Have you ever seen a tall tower and wondered how it's able to stay up without falling down? The science of towers and their stability is referred to as geotechnical engineering. Geotechnical engineering involves several factors that affect tower stability. Among them are the slope of the angle that the tower is resting on, if there is a slope, the soil around the foundation of the tower, and the height of the tower. In my experiment, I aim to test these three variables and see how they affect tower stability. My hypothesis was that the higher angles of slope would negatively affect tower stability, and that less dense soils, such as silt loam, would perform more poorly than more dense ones, such as sand. I also hypothesized that higher towers would be less stable than short ones. To understand the setup of my experiment, you first must understand the base setup without any of the variables. We prepared a slope like this one, with a 10-brick stack here, and rain guttering here filled with dirt. We then placed a 10-brick tall Lego tower taped together so that it acted as one unit rather than several individual Legos, and buried it as far down as possible inside the dirt, and we used a level to make sure that it was 90 degrees straight up. We then rolled a baseball from the top of the incline here so that it hit the tower, and then we measured the amount of displacement left in the soil there. Now, then we split off into the three separate experiments with their individual variables. The first experiment concerned the slope angle. To do this, we changed the amount of bricks in the stack here. We did 5 repetitions with the short stack of bricks that had 8 bricks, 5 repetitions with the medium set of bricks found in the base set, and 5 repetitions with the 12-brick tall stack. We then set it back to a 10-brick tall stack so as not to mix variables, and went on to the soil type portion of the experiment. In this one, we were changing the type of soil found inside the rain guttering. Here we did 5 repetitions with the silt loam in the base set, 5 repetitions with gravel, and 5 repetitions with fine sand. The last portion of the experiment, we were testing how the height of the tower, the Lego tower, affected its stability. Here we did 5 repetitions with the short Lego tower that was 8 blocks tall, 5 repetitions with the medium block tower, which was 10 blocks tall, and 5 repetitions with the 12 block tall Lego tower. We also calculated the arctangent of the separate slopes found in the first experiment. The 10-brick tall tower came out to be 31.7 degrees, the 8-brick tall tower came out to be 24.05 degrees, and the 12-brick tall tower came out to be 35.54 degrees. In the slope experiment, the short stack of bricks averaged at 9.0 millimeters. The medium stack of bricks in the base set averaged at 12.6 millimeters of movement, and the 12-brick tall stack of bricks results averaged at 20.6 millimeters of movement. In the soil types, the silt loam's results averaged at 10.4 millimeters of movement, the gravel's results averaged at 12.2 millimeters of movement, and the fine sand's results averaged at 20 millimeters of movement. Finally, in the tower height portion, the short Lego tower's results averaged at 13.2 millimeters, the medium Lego tower averaged at 15.4 millimeters of movement, and the 12-brick tall Lego tower averaged at 10.0 millimeters of movement. In conclusion, in the slope portion of the experiment, my hypothesis was proved. The higher slope afforded the tower less stability and gave the ball more power as it rolled at the tower, and thus it moved more. In the soil type portion of the experiment, my hypothesis was disproved. I hypothesized that sand would outperform silt loam, but in fact the opposite was true. Silt loam actually performed the best out of 3 soil types, and sand performed the worst. Finally, for the tower height portion of the experiment, my hypothesis was disproved again. The short tower performed better than the medium tower, but the tall tower performed better than the both of them. My hypothesis is that this is because of the added weight on the tall tower. In conclusion, this experiment's results would have practical application in geotechnical engineering and in architecture to ensure stability in towers. Any questions?
If you were going to extend this project, how would you do it?
I don't know. I might mix up the variables a little bit, see how that all comes into play. Like, combine all these a little bit to, like, test slope and soil type at the same time to get a more accurate standard of comparison to see which one affects it the most.
How could you determine if what you're thinking on the weight of the tall tower contributing to the stability? How could you test that?
Well, you might be able to put that off as its entire own experiment and start with a very short tower and go off one block at a time and measure individual results and averages from that point on and see if somewhere between 10 blocks and 12 blocks the performance goes up like it did in this experiment.
Thank you.
You're welcome.